Dun, 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 dun. All right, we're here. It is 2:30 UTC. Wow, I made it right on time. Can't believe it. Can't believe it. So yeah, well, welcome everybody. Welcome again to Astronomy Daily Live. A little late version tonight, maybe a little short as well because it is clear here, and I'm taking advantage of this little hole in the clouds between storms. We had a storm blow through last night. We're going to have another one blow through tomorrow, but it is clear here tonight, so I'm taking full advantage. Took my calibration data about an hour and a half ago at sunset. I did the t-shirt flat, and all right, hey, we've got an ever-growing panel. Notice that Tim just came in. Hey there, Tim.
Crap.
I don't know if he can hear me yet.
I botched.
And well, Tim is here. Bobby is here. Hey, Bobby, can you hear me all right?
Hey, what's up?
Hey,
What's up, Tim?
Tim, can you hear us yet?
Hi, guys. Hope you're okay.
There we go. There we go. Yeah, hope everybody's well. As I was saying, a little bit of a late-ish start because I took some calibration data earlier, and then I realized it's like, well, you know, I probably need to eat something today. so that happened. I said, well, hey, you know, I've got a little bit of time. I said, you know, I'd start the live stream tonight at 2:30. And so I went outside, and it's like, oh, you know, I'll do the star alignment. That shouldn't take too long. I was defocused, right, because I had my webcam on there for the Venus event. And so I knew that I had to refocus, right? So I started snapping images and moved the telescope to a bright star, Capella. And I knew that I was way out of focus, right? So the stars would look like donuts, right? Or even worse, right? Depending on the size of the donut, I might be able to see it, I might not, right? So I spent, and you know, this is how stupid I could be sometimes, right? So I spent about 15 minutes trying to focus, right? It's like, I'm not seeing anything, right? I'm not seeing any brightening. I'm not seeing anything at all. And it's like, what is going on? What is going on? I finally looked, right? I looked kind of carefully, right, at the computer screen. And when I take my calibration data, oh, I'm going to have to refocus now. Sorry about that. Pop. There we go. When I take my calibration data, I take flats, and then I take darks that go with the flats. And I've got a setting on there, you know, to take darks. And what a dark is a certain length of exposure, but the shutter on the camera itself doesn't open, right? So no light actually gets in. It's a dark, right? Well, I have that set still to dark. So for 15 minutes, I was trying to focus on light that just wasn't there at all. And so I finally, you know, realized this, and it's like, oh man. So, you know, turned the shutter on, looked right away, saw the donut, focused in like 2 seconds, right? It was that easy, right? That's how long it should take. So, you know, these are some of the trials and tribulations that the observational and research astronomers go through, right? You have to deal with not only the instrumentation, you know, not doing its thing, but sometimes it's just the stupid operator that just isn't doing the right thing. Okay, well, I haven't actually done a star alignment yet, but I will be once this live stream is over, and that. So you know, just some dumb stuff. All right, Tim has rejoined us. Tim, are you there?
Yeah, I'm just having a little bit of trouble at the moment.
Trouble everywhere. Yeah. All right. Well, hope everybody's doing well. You know what I didn't do, and I need to do this right now, is I need to I need to pop out the chat, and I need to stop this, because otherwise my poor machine is going to come to its knees and nothing is going to happen here whatsoever. All right, I've got the chat. All right, Uncle Bill is there.
I'm going to come out and rejoin.
Okay. Space TV, weird. Hey. Space TV, everything okay with me? Everything's great. I've got a clear sky. It's cold. Oh, it's cold. You can see I'm sort of dressed up. I've got my little hat
on that monitor,
so we can hear you, Tim.
Oh, sorry.
That's all right. We just don't, you know, don't want any you know, things that you're going to have to, you know, answer for later. So yeah, got the little hat, got the little hood, got the little gloves. It's probably right now, it's probably about 2 or 3 degrees Celsius out there right now. It's supposed to get well below zero, probably I want to say like maybe -6, -8, something like that. So yeah, it's going to be a little bit cold, but I'm not going to be out there incredibly long. But yeah, sort of had to do all that first. Had to get some dinner and at least attempt a star alignment, which yeah, you know. All right, well, cool. Let's see. Tom is in the chat. Hey there, Tom. ERRT Radio is in the chat. Hey, nice to see you there. This is going to be a shorter version of the live stream, mainly because, you know, we started late, and I don't want to go too much past about 3 hours UTC, just because, you know, I definitely respect everybody's time, and I think it's great that you all come in here at all. I think it's absolutely fantastic. So, Tim, you got everything worked out?
Yeah, got it all sorted out now. I was messing about with 2 different monitors and the time difference.
Yeah, you know, that's one of the problems with living on a sphere, right? Is that it's like, hey, oy vey, you know, this time things. It's just absolutely crazy. That's why I have one time and that's it, right? That's as much as I can handle is one time. So all right, well, cool. Well, welcome everybody. Welcome. Yeah, just the scope is pretty much set. I still need to do another alignment on another star. I need to focus a little bit, and then I'm going to proceed with doing some photometry tonight. I'm actually looking at a series of 38 stars in a little tiny section of the sky that are all 11th magnitude and brighter. And I'm measuring the brightness of these stars and then comparing those brightnesses to the measured brightnesses of the Gaia spacecraft, which is in orbit around the Earth looking at billions and billions of stars and measuring their brightnesses, their positions, their motions, all of that. And so Gaia is, I assume, they're doing everything right, and they are, properly measuring brightnesses. So I can use Gaia as sort of a standard to compare to my measurements. And the idea there is that I want to see how um, close my measurements are to Gaia's measurements. And what I've seen so far is that I'm getting to within like 30 or 40 millimagnitudes. So that's 0.03, 0.04 magnitudes of Gaia pretty consistently for stars anything brighter than about like 11 or 12 or so. Anything fainter than that, like a 13th magnitude star, a 15th magnitude star, I'm getting up around like 200 or 300 millimagnitudes instead. So that's not incredibly acceptable, but there are a lot of targets that are 11th magnitude and brighter. So yeah, making these kinds of measurements will increase my confidence. I'm already pretty confident, but the more measurements I can make that are close to what Gaia says they are, then the more confident I'm going to be, because when I move into sort of science mode, actually making scientific measurements, looking at variable stars or looking at galaxies or whatever I'm doing, I want to be confident that the measurements that I'm making are correct, right? Because when I publish my results, I want to be as close to being correct about things as I possibly can.
Yeah.
So that's the whole point.
So, Ear Radio wants to know, you showed a star at least last night. What was the bright one? And we're at the Alan Taxis Limited.
Alan Taxis Limited. Hey there. Nice to see you in the chat. So this is Astronomy Daily Live. We talk astronomy here. Of course, tonight's live stream is a little bit shorter because I'm starting a little bit late, and I don't want to take up too many times.
And if you check the chat, Air Radio was asking the question.
Yeah. So I showed a star maybe last night. What was that bright one? Oh, Ron, what you're gonna? Yeah, I can't be absolutely certain what exactly you're referring to. So you might have to go back and look for yourself. That's all I can really do, because I can't be absolutely certain. I know last night we were looking at a planetary nebula. Don't remember the NGC number there. Bluish white. Yeah, it definitely was not Vega.
Era Radio is saying it was bluish white Vega lately.
Yeah, I don't. It was definitely not Vega. We were looking at a couple of stars in the constellation of Corvus the other night. So maybe it was one of those. Can't be sure. Can't be sure at all. Capella. The only reference to Capella that I have is that we were looking at Comet Wirtanen the other day, and it had passed by Capella. But Capella's red, so yeah, that's not going to do it. Best I can suggest, ERRT radio is to go back and look for yourself, because that kind of information, it's gone, just it's out there. Don't know.
I'm not sure if Tim knew. I'm not sure if he's on the Discord, but maybe you should tell Tim about Autolotto's got a good offer from her observatory.
Oh yeah. I definitely encourage all of you to go over to my Discord server. There's a link down in the chat, and I think Nightbot.
I actually had notifications on for Discord on my phone, but because the time difference, it was like 3, 4, 5, 6, 7 a.m.
Yeah, of course. Yeah. Anyway, one of our semi regulars here is now helping out a local public observatory. She did a bunch of fundraising and stuff for them. So they basically said, cool. Hey, do you want a job? And she's like, well, yeah, but instead of getting paid, can I just sort of store my telescope here? And they said, sure. So yeah, she's that's kind of a nice thing, because she doesn't have to lug all that stuff around. And I think I think she said that she was like 30 minutes away or so. So to have to lug everything out into the car, all right, and then drive there, and then lug all the stuff out, set it up and everything. Now she just has to drive there, right? So that's very, very cool. That's very, very cool. So yeah, and she sort of points to this live stream and the participants of this live stream in getting her going on this adventure. But I think a lot of it is her too. She's absolutely fantastic. So she seems to be the kind of person that it's like, she wants to do something, she's going to go and do it. And so yeah, I think that is absolutely great. All right, well, let's do an object of the day. And now Nightbot can do that for us. So we can either do that, or I can go over to random.org and we can choose a random number.
Have Nightbot do it.
Have Nightbot do it? All right.
Mm-hmm.
We will put Nightbot to work. So the command there is just NGC, I think, and it should pop up a number here on the chat. And that is the NGC object that we will look at. So there are 7,840 of these objects. Most of them are galaxies, but there's also globular clusters, open clusters, nebulae, both planetary nebulae and gaseous nebulae. So, but like I said, most of them are galaxies, because that's just what there's a lot of. But all right, well, here we go. So Nightbot has chosen, supposedly randomly, NGC 1359. So let's see. The NGC numbers are usually ordered by right ascension, right? So the smaller numbers like this one are going to have a smaller right ascension. So 1359. Let me grab my.
12.
Oh no! It's out of arm's reach.
In the constellation Eridanus.
Cool.
Eridanus.
Yeah. So 1359 divided by 7840 is that times 24. So my guess is that it's around 4 hours 10 minutes if I just go by the NGC number, but we will look it up here. And Tim already has, which is very cool. But what I'm going to do is I'm going to pull up Sinbad, and we will take a look. So I'm going to pull up Sinbad, and then I'll share my screen here. Let's see, share the screen. Dun, 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 dun. There we go, to infinity and beyond. Okay, so we are going for, I already forgot what it was, 1359. Take a look and see what this is. The fact that it's over there kind of indicates that maybe it's not a galaxy. Oh no, I forgot it again. Is it 1359? Yeah, okay. Man, I'm terrible with that. But maybe a cluster? Nope, it's a galaxy. All right. So, right ascension. So these are the celestial coordinates here. These first ones here. So 3 hours, 33 minutes, 47 seconds, and then a declination of negative 19 degrees, 29 minutes, 31 seconds. So it's below the celestial equator.
You
Looks
might
like
want
it's
to
another.
zoom out so we can so we can see the galaxy.
Oh, I'm just going to go over like that. See that?
Can I ask a really newbie question?
Absolutely.
The minus 19. You said it was below the equator.
Yeah. The
I
celestial equator.
I don't even know what that is.
Let's go over really quick and look at a graphic of that. That's probably the easiest thing. What I'm talking about is this thing called a celestial sphere. S-P-H-E-R-E.
Sorry for the newbie question.
Everything is welcome here. Now, let me see if I can find sort of a decent one, because that is not a very nice one. See if we can find something. This one, maybe this one. Maybe this one. So I'll zoom in here a little bit. So, oh, come on. Trying to zoom in here. It's fighting me. Okay, so here's the Earth. Of course, the equator of the Earth is here. So if you extend the equator of the Earth
extend it outwards.
Yeah, outwards, and also the poles, right? That's what we're talking about, right? So if you were standing on the equator of the Earth and look straight up, you would see the celestial equator right at your zenith, right at the top, right? If you were standing at the poles, the equator would be on your horizon.
Horizon
instead,
level, yeah.
Right?
That makes sense. Thank you.
Right. So it's just an extension of the Earth's system, and we divide things up in longitude by right ascension, and it goes from west to east, and declination goes from 0 degrees here to 90 degrees north and 90 degrees south. So it's 180 degrees, from north to south, and then, of course, 360 degrees all the way around. But that's actually 0 hours to 24 hours all the way around. We divide that up in terms of time, right? So 1 hour of right ascension is actually 1/24 of 360 degrees, which is 15 degrees. So that's how that works. It's just a coordinate system, and there are several of them. Yeah, there are 3 that are normally used. there are two shown here, celestial and galactic. So you can also have galactic coordinates as well. So it gets really confusing really fast, but this is really the most important one. That'll get you there.
I prefer the first explanation. That one makes sense to me.
Yeah, yeah. And, you know,
Thank you.
Yeah, and most telescopes, you know, use this kind of coordinate system just because it's the easiest one. All right, well, cool. So this is saying that it's some kind of barred spiral, but looking at the image, wow, that's a little bit distorted there. So yeah, we'll have to come back and sort of see what that's all about. So let's see. It's actually, we and it are moving towards one another at a pretty good clip, almost 2,000 kilometers per second. So that's kind of interesting. Most galaxies are moving way away from us, right? But this one is actually moving towards us. That's kind of cool. That's kind of cool. Pretty small, right? Smaller than 1 arc minute along its major axis. Minor axis is even smaller. But wow, this is really distorted. We're going to have to come back and examine that. Really faint, though. B is towards the blue part of the spectrum. R, as you can probably guess, is towards the red part of the spectrum. I, J, H, and K are towards the infrared. So you can see that it's actually brighter towards the infrared than it is in the visible, which is pretty typical for these kinds of galaxies. There's a lot of gas and dust, and those tend to be brighter in the infrared. So pretty faint, right? You're going to have a pretty sizable scope to see this with your own eyes. Something like that, you would need at least like a 10-inch or a 12-inch telescope. Put an eyepiece on there, take a look, and what you're going to see is basically just this bright central part. This, of course, is a long exposure. We can zoom out a little bit here. This is a long exposure, so you know, of course, you're able to see a lot more. Looking through a telescope with your own eyes, you are definitely not going to see that at all. You're going to see a little gray, fuzzy thing, maybe right in there, right? And that's about it. So, you know, but you put a camera on there, do a long exposure, you'll do really well. So, of course, a bunch of different names, bunch of different catalogs. These catalogs, they usually, you know, are looking for some kind of characteristic, you know, either shape or, you know, star forming regions, or, you know, really bright in the X-ray or bright in the infrared, you know, or something, right? So most objects, most objects have multiple names, and this is no exception, right? So quite a few references. That's kind of nice. We'll come back to that. Let's see how far away this is. Now, the fact that it's so small, right? So small and so faint tells me that it's either you know, intrinsically small, it just is small, or it's pretty far away. Now, the fact that we can sort of see some detail here means that it can't be incredibly far, you know, because we're seeing, you know, some clumps of things and some structure in here and all that. So yeah, it can't be incredibly far, but being that it's that small, my guess is that it's probably pretty far away. Let's take a look. Yeah, that's pretty far. So not good agreement here. Not too bad. Let's see, 38 and 28. Let's take the average of that. 38 plus 28. So that's 33. So about 33 million parsecs away. That's what this MPC is. So of course, a megaparsec is 3.26 million light years. And then we're going to multiply that by 33. So you get like 107 million light years away. So
Holy moly!
yeah, you know that's not really far. Of course, that's not really close either. Um, that's sort of, you know, in the larger neighborhood.
Can we see it enough to see if it's a binary system or not?
A binary, like a binary galaxy?
Yeah.
Well, you're seeing what I'm seeing here, and I'm not quite sure what I'm seeing here, right? There's a little bit of brightening here, which I would sort of expect, but there's also this. So, you know, this is saying that it's a galaxy in a pair. So maybe these are the two here, and they're interacting, having some stuff flying off that way. That's my guess. So let's
Definitely
see.
huge.
Yeah. So pretty good agreement in terms of how fast it's moving, right? They all seem to point to around almost 2,000 kilometers per second. And I guess, yeah, if it's positive, if that's a positive, that means it's moving away from us. That makes more sense. That makes more sense. Most galaxies are, right? Most galaxies are. That's sort of the nature of the universe.
Expanding.
Yeah, yeah. At least that's the theory. All right, well, cool. Let's. I wonder. I wonder if HST has ever imaged this thing, because this is kind of a crummy image. This is taken with the Digital Sky survey. Looks like it's a little overexposed. I don't know. I don't think the Sloan Digital Sky survey has this in its catalog. Yeah, it's coming up black. So let's do a quick look and see if HST has ever observed this. NGC 1359. So go over to the HST archive. NGC 1359. We'll just look at it all here, whatever's there. Probably nothing, but yeah, you never know. Nope, nothing. Ah, bummer.
Dang it.
Dang it, dang it, dang it. Yeah, well, that's how it goes. It's definitely been studied a little bit, though. There are supposedly, you know, some references here. So let's take a look, see if there's anything particularly interesting here. So surface photometry, color gradients. Okay. So galactic bars at 3.6 microns. So 3.6 microns is definitely in the infrared region, not exactly the thermal infrared. Thermal infrared starts, I think, about 10 microns or so. So yeah, you know, this is sort of not visible to the naked eye, but not really in the thermal infrared either. So let's see, stellar mass, morphological features in the Spitzer survey. Let's see if there's anything, any paper that actually specifically references 1359. It doesn't. Nope, there's no papers specifically reference 1359. That's a bummer. Luminosity classification, H2 regions. So that's typically the H2 regions. That's singly ionized hydrogen. So that is usually, sort of these brighter regions here, which are probably, like star-forming regions, big nebulosities and whatnot, like that. So they were definitely looking at that. Quite a few references. I don't know. I probably don't want to go through all of these, but ooh, getting dizzy. There we go. 21 centimeters actually neutral hydrogen. So let's take a look at that. That might be interesting. Just sort of see what this galaxy looks like, maybe in neutral hydrogen. Let's see if they have an image of that. Sometimes it's just spectroscopy, but maybe they were doing some imaging too. Take a look here. I like to go to the source if we can. Study of spiral galaxies from 392 new measurements. Later have been detected in the 21 centimeter line of neutral hydrogen. Radio telescope, of course. These are in the radio frequencies. Kind of short radio, right? That's 21 centimeters is something like, I forget what the conversion is. I'd have to do that. I'd have to look that up. But I think it's something like 43 megahertz. Don't quote me on that. But let's see if there's some images or if they're just talking about like spectra or something else. I'm seeing a bunch of histograms of various parameters, discussion of distances. Okay, so here's a bunch of data. Is our guy in here? 13. Oh, what was it again? 1359? Yeah. Oh, I can't remember that. 1359, right there. Zoom in a little bit here and see. So let's see what we're looking at here first. So luminosity in terms of the sun, distance, mass. Okay, so let's sort of see. This column here is in terms of billions of solar masses. So let's see at least what they think this is. So 6.85 billion solar masses. So that's a couple of stars, right? Not too bad. And well, in terms of luminosity, now in terms of mass, that's this column. 4.67 billion solar masses. So, yeah, that's not actually very big. I think I want to say that recently somebody has tried to measure the mass of the Milky Way, and I think it was somewhere around like 400 billion. So compared to the Milky Way, this thing's just a puny little thing. It's like 1% of the size of the Milky Way. So that's kind of cool. These are just a bunch of ratios, and okay, here's a distance too. Let's sort of see what the distance is. So they got 19.6 million parsecs. So yeah, I think what we were seeing was like 33. So yeah, there's, measuring distances is hard, and comes down to um, making sort of an educated guess. And so these numbers can be all over the place. And I think in this case it is, right? So that might be a little bit short. Who knows? Who knows? We really don't know. That's pretty cool, though. I wonder if there's anything else here. Don't know if there's going to be any pictures or anything, because they were looking at this in the radio, and I think this is from 1982. The technology back then in the radio really wasn't allowing for pictures to be taken, and that's even hard to do now. So, all right, well, cool. That's kind of neat. Let's go back and, oh, did I do that? There we go. Oh, one more. It's going to put me all the way at the top, isn't it? You turkey. Let's go down to 1982. Surface photometry catalog of ESO Upsala galaxies. Okay. Supernova rates. Southern Galaxy catalog. Oh, let's go up in time here. Ding. Groups of galaxies within 80 megaparsecs. Determination of nearby groups. Preliminary classification scheme for central regions and late type galaxies. Quantitative. The APM Bright Galaxy catalog. So the Teller-Fisher relation is one of the ways to measure distances. Sort of a complicated way of doing things. I forget exactly what the parameters are here, but yeah, they're trying to measure distances. Because once you have a distance, you can sort of infer all kinds of other things in terms of how bright things are, and if you know how bright things are, you can tell what the temperatures are, what the ages are. There's lots of things that you can do once you have a distance. So, but distance is the hardest thing to measure. So. Size, right? And once you know a distance, you got a good idea as to what size things are. And if you know size, you can get densities and yeah. But it all depends on distance. So here's another Tully-Fisher guess. Bulge disk decomposition. Not quite sure what bulge disk decomposition is. Like that. Nearby optical galaxies. Yeah, this sort of just looks like they have been looking at this a little bit, just kind of using it to find out all kinds of things, or try at least to find out all kinds of things. So the H1 content of the Eridanus group of galaxies. So maybe this galaxy pair is sort of part of a larger group. Is that what that sort of implies? Let's see here. Grab the paper here and see what's going on with that. The H1 content of galaxies in the Eridanus group is studied using GMRT observations and the high-pass data. So yeah, you know, we'd have to look all that up to see what that actually is. H1 deficiency in galaxies is observed to be directly correlated with the local projected galaxy density and inversely correlated with the line of sight radial velocity. Okay. Tidal interactions, yeah. Significant evolution of galaxies can take place in the group environment. Oh, okay. So spiral galaxies and the cores of clusters of galaxies are known to be deficient in neutral hydrogen. Oh. Well, that's an interesting observation. And I guess, you know, this paper is talking about why. So that's pretty cool. Galaxy harassment. Man, even out there, there's galaxy harassment.
Set of bloody bullies.
Yeah, and look at this, galaxy starvation. Man, it's a harsh universe out there. You got harassment and starvation. Gee whiz. It's, you know, I thought it was nice out there.
What is galaxy starvation?
Well, it says right here, hot gas and the halos of galaxies is stripped. So you even have strippers out there. Amazing.
I'm going.
So yeah, you know, what they're talking about here, I think, is that, you know, when you have a cluster of galaxies, you know, there are, you know, gravitational forces and everything else. You know, now they're extremely small, but over time and over great distances, that can be significant. And so if you have an object like a spiral galaxy that usually does have, you know, pretty hot gas and, you know, gas and dust and all this kind of stuff, if that spiral galaxy finds itself in sort of the centers of these clusters, the gravitational force from all the other galaxies is going to you know, cause some trouble for the spiral galaxy there. So, you know, they're being harassed and starved and stripped. So yeah, that's brutal, absolutely brutal. But that's what they're observing. And I guess, you know, this paper is trying to talk about maybe why, right? Maybe why that's taking place. So, but again, let's search for 1359 and just sort of see if that particular galaxy is referenced. Ah, it is. So under tidal tails, which we already know, you know, we looked at that already, and yeah, you know, there definitely was a little tail coming off of there. I don't know if you saw that or not, but let's go back and look. Where is it? So they're probably talking about this, maybe. Let's well, yeah, let's stick with this for now. Ah, look, there's a figure 7. Let's take a look at figure 7. Where is figure 7? Ah, that's figure 8. So probably back here somewhere. Come on, figure 7, where are you? Okay, so yeah, so you can sort of see underneath, they've got probably what this is. Yeah, okay. So actually, this is the Digital Sky Survey. So this is exactly the same as this. They've just messed with it a little bit, but then they've overlaid um, column densities. So they've actually measured the amounts of hydrogen in these areas, and found out like how much there is, and then just overlaid it on the optical. And yeah, you can sort of see that there is, there does seem to be sort of a stretching out this away, right? See
So
how
that,
Go
pardon
ahead,
me,
Tim.
that right-hand side image, the one showing the two objects,
That one, yeah.
does that show then that it's a binary?
I guess so. This is a different object though, too, right? This
Oh, I
is
beg your pardon.
yeah, this is
Yeah.
1482. This
Yeah.
is the one we're looking at here. Yeah, this, again, this is just showing concentration of neutral hydrogen, and it does look sort of double lobed, so something is going on there. And when we look at this in visible wavelengths, it is extended, right? It's sort of longer this way than it is that way. So yeah, hard to tell, but that seems like it's a double lobed thing of some sort. But this most definitely has some kind of stuff over here where, most of the rest is concentrated here, but it's got this little tail. So let's see, what do they say about that? Tidal tails. So 1385 and 1482 are far infrared luminous galaxies. 1385, highly asymmetric. No tail is seen. 1482. So yeah, that's kind of interesting. They only mention it once here, but there's a lot of references to 1359. So let's see. Let's see what else they have here. This just looks like just some observations that the VLA made. The VLA is the Very Large Array over in Socorro, New Mexico. It's a bunch of radio telescopes. Really, really, really cool to see that if you ever get a chance. But yeah, this is just giving position and size and all that kind of stuff. So that's sort of a little bit of what we already know. H1 emission was searched by eye, and the channel images, the H1 moment maps were constructed using the field 1 and field 6. Ooh, okay, so let's look for figure 9. Also, let's take a look here. Okay, so yeah, so this is just a wider field of view, right? Here's our galaxy here, and this is just a larger field of view. They're actually measuring the velocities of this gas, right? So kind of neat, identifying a few galaxies around it for what they're worth. And it gives you a scale here too. That's kind of nice.
So meters per second, that's fast.
Yeah, that's a little fast. That's a little fast. Let's see. So what else did they say about here? Shows extended H1 tails. Okay. I guess my guess is that this is probably what they're talking about, an extended H1 tail. So yeah, lots of things going on there. Let's see, what else we have here. Both NGC 1482 and 1359 are in the subgroups of which they are the brightest members. Both galaxies show tidal features in their optical images. 1359 has 2 nearest neighbors. The streamers don't connect them. Multiple interactions, they're thinking. Cool. Lots of action. Lots of action. Yeah, you know, because the closer in one showed sort of a tail here, and you sort of get an indication of that here. See how these are a little bit more spread out than they are here, right? So that means that there's more stuff. And then there's also this thing too. So yeah, lots of cool stuff going on there. Interacting more than once. Kind of cool. 2 nearest neighbors, yeah. Okay, so there's just that. There's just that. NGC 1359. Okay, what's this table? It's a big, huge table. Okay, yeah, so they're just, again, you know, they're just giving, you know, some basic info about how far away they think it is and how fast it's moving. Cool. 1359. That's it. That's it. Oh, okay. Well, you know what? I'm looking at the time, and I'm thinking that I am wanting to get out under that dark sky. So I think I'm going to do that.
Yeah, sure. I'm having some technical transgressions with my network.
Technical transgressions?
Yeah, some technical difficulties.
Yeah. Well, you know, I think I'm going to get out of here for today. It's 3:27 UTC, and I think that's also Tim's time. Crazy guy over there. So
3:28, yeah.
Yeah. So I guess I'll let you go for today. A little bit of a short one, a little late, a little short. But yeah, I think I'm going to get out under the sky and go collect some photons for a little while. See if I can spend at least a couple hours out there getting some data. So, all right, well, I'm going to get out of here for now. So thanks everybody for coming in. Sorry for being a little bit late, but that is the life of the astronomer. So it looks like the next couple of nights are going to be cloudy here, so won't have anything to do out there. I've got to take advantage of these. Yeah. You know, I definitely have to take advantage of these nights where there's no moon and it's clear. So you know, those are sort of the 2 parameters that I go by. So. All right. Well, for now, I'm going to get out of here. So thanks for coming in, everybody. Have a great evening, a great day. Just got a couple more days in this year, and it's over. It's over. Yeah. So pretty amazing.
Thank you very much, Matt.
Pretty amazing. Yeah. Well, thanks for coming in again. And let's do this again soon. How about in about 22 and a half hours?
On the spin.
Yeah. Let's do it. On the spin. All right, you guys. Take care. I will see you later. Bye.